Hi, it's Mr. Baker here, and today we're going to be looking at momentum. Okay, so today we're going to be looking at momentum, and we're going to be answering this question: why is it difficult for a superhero to stop a moving train? So let's have a look at this to start off with. So I'm going to throw a ping pong ball at our superhero, and we're going to see if they can stop it easily. Not necessarily catch it, but how easy it is to stop. So okay, let's throw it. So anyone pretty much could stop a ping pong ball, couldn't they? If you threw a ping pong ball at somebody, no matter really how fast you threw it at them, they'd be able to stop it. How about if you threw a medicine ball at somebody? Okay, so if you throw a medicine ball is one of those balls that they use in gyms. Some people apparently use them to keep fit, and they're a lot heavier. So they're a lot heavier, and they would be difficult to stop. So we know, because we've lived on this earth, that when we trying to move stuff about, heavy things are quite difficult to move around, and light things are a lot easier. And we also know that if I threw things faster at something, it would be harder for that thing to stop. So the faster something goes, also the harder it is to stop it as well. Okay, so that's kind of the basis of what momentum is. And all moving things have got momentum, and it's really a measure of how difficult it is to stop something that's moving. I mean, that's not the definition of it. We're going to look at an equation which is the definition of momentum, but if you in your minds get that idea that the momentum is a measure of how difficult it is to stop a moving object, then you'll get the idea of what momentum is. So if I've got two cars and they've got the same mass, but one is quicker than the other, which one's going to have the most momentum? Well, it's going to be the faster car, isn't it? And if both cars are travelling at the same speed or the same velocity, but one is full with luggage and the other is empty, which one's going to have the most momentum? Well, it's going to be the heavier car, isn't it? Okay, so the bigger an object, or really the heavier an object, and the faster it moves, the more momentum it will have and the more difficult it will be to stop. So we've talked about what it is, we've described what it is, but we can use an equation to define it, and this is our equation. Momentum equals mass times velocity. Mass is measured in kilograms, velocity is measured in meters per second, and momentum is measured in kilogram meters per second. So we've defined what momentum is. We're using velocity. So velocity is a vector quantity, and that means that it's got a magnitude and it's got a direction. Scalar quantities such as speed only have magnitude. So as velocity is needed to calculate momentum, momentum must also be a vector quantity, and therefore it has a direction. So if two objects of the same mass are moving in opposite directions but at the same speed, i.e. their velocities are different, the momentum of each of the objects will have the same magnitude but a different direction. So momentum has the size and direction, and we normally indicate direction in physics with a plus or a minus. Plus is normally to the right and minus or a negative sign is normally to the left, but you can assign those directions however you want. Okay, so because we're using velocity in our equation, and velocity is a vector, that means that momentum is also a vector because we're using velocity. So that means that momentum must have a size and it must have a direction. So you must describe momentum as having a certain size but in a certain direction because it's got a velocity to calculate it. Okay, let's have a couple of examples to look at. So we've got an aircraft carrier. An aircraft carrier here has got a mass of 1 million kilograms and a velocity of 15 meters per second. So what's its momentum? So we know that momentum equals mass times velocity. The mass is 1 million kilograms, the velocity is 15 meters per second. So that would have a momentum of 15 million kilogram meters per second. And this also, the kilogram meters per second, a lot of the time when we're talking about units, we will talk about meters per second, something like that. But here we're talking about kilogram meters per second. Okay, so our unit is calculated, or the way that we get our unit is by looking at the units here and the units here, and because we've got a times sign here, we're multiplying those two units together as well, so it's kilogram meters per second, and that's our unit for momentum. Right, a little challenge for you here now. So we've got a few different examples here. Be careful, there are a couple of little tricky ones towards the end. If you have a go, pause the video, and then I'll show you the answer when you have done it. Okay, so pause it there. Okay, if you paused it. Okay, right, let me go through it with you now then. So, if we've got a mass of 50 kilograms and a velocity of 3 meters per second, mass times velocity equals 150 kilogram meters per second. In our second one, we've got a velocity of 20 meters per second and a momentum of 160 kilogram meters per second. So we've got to rearrange our equation to find mass. Now, if momentum equals mass times velocity, then mass equals momentum divided by velocity. So 160 divided by 20 equals 8 kilograms. And for the third one, momentum is 1,500 kilogram meters per second. The mass is 250. Now, if momentum equals mass times velocity, then velocity equals momentum divided by mass. So 1,500 divided by 250 equals 6 meters per second. Now, the fourth one there, we've got a mass of 500 grams and we've got a velocity of 8 meters per second. So 500 grams, our unit for mass, remember, is kilograms, so we've got to convert 500 grams into kilograms. Now 500 grams is half a kilogram, it's 0.5 kilograms, so 0.5 times 8 equals 4 kilogram meters per second. And on the last one there, we've got a momentum of 3 kilogram meters per second and a velocity of 50 centimeters per second. So we've got two things to do here. We've got to change 50 centimeters per second into meters per second. So 50 centimeters is 0.5 meters, isn't it? So that would be 0.5 meters per second. And then we've got to rearrange our equation. If momentum equals mass times velocity, then mass equals momentum divided by velocity. So 3 kilogram meters per second divided by 0.5 meters per second equals 6 kilograms. How did you do on those? Hopefully they were not too bad. And that's pretty much the end of this lesson. So these are the things that you should be able to do by the end of this lesson. You should be able to describe what factors affect momentum. You should be able to apply the equation P equals mv. Now, we didn't actually talk about this. P is momentum, so that's the symbol for momentum. M is the symbol for mass, and V is the symbol for velocity. So we can, in shorthand, we can write down our equation momentum equals mass times velocity, P equals m times v, and we should be able to use that equation to find momentum, velocity, or mass of an object. And you can also explain that momentum is a vector. In other words, it's got a direction as well as a size. So why is it difficult for a superhero to stop a moving train? Well, a moving train has got a lot of mass and it's also got a lot of speed, most probably. So with a lot of mass and a lot of speed, you can have a lot of momentum, and it's going to be difficult to stop that train, even if you're a superhero. So that's the end of this lesson on momentum. I've been Mr. Baker, and I will see you next time.